Hello, and to follow up from our lecture on molecular simulations and molecular visualization, today I will be walking you through a molecular visualization software called PyMol. So here is a PyMol session. So when you click on the icon of the software PyMol, or when you type PyMol into a terminal, this interface should come up. You can load molecular structures into this software, and it will show you what the structure look like. So a very good example here is that I can go to File and Open and load my structure of interest. In this case, I save it in on my desktop. For example, I can load these structures of an ion channel called Kia 2.2, which is an inwardly rectifying potassium channels. This is one way of doing it. So you need to have a PDB file coordinate, or the other way of doing so is you can use a command called fetch. So FETCH. So fetch command will load a molecular structure directly from the PDB database. So for example, I can load a structure such as an KATP channel or ATP sensitive potassium channel, which is an inwardly rectified potassium channel, so which has a code of 6BAA. So if I type fetch 6BAA in, what PyMol will do for me is that we automatically load a molecular structure of my interest onto the software. Now, there are two things I could do with this loading up of the structure. First, if you look on the right-hand side panel of this, you will see the three tabs. You see All, Fixed, and 6BAA. These indicate which structures are we working on. So if I click on 6BAA, it will hide my 6BAA structures. So I could work on one protein at a time. If I click on Fixed Kia 2.2, I can work on the 6BAA at once. So this will help us to be able to work on these structures and play around with it and look at the part that you're interested in. To hide all the structures, there are two ways of doing it. Let's just work on the fixed structure for now. So I will just delete this one so I can go on Action and delete object. So this can be gone for now. Now, if I would like to zoom in on this structure, I can go on Action and then Zoom. So I can use that to zoom in onto my molecular structure. The other way that I could do that, so if I take that in a very weird angle, I can also type in zoom in my command here, and what it will do is that it will automatically zoom in to my structure, similar to the action I use on the action button. Normally, if you are beginners in the technique, I would strongly recommend you use the command on the right. However, if you come from a computational or structural biologist background and you would like to do things very fast, I would strongly recommend you to use this terminal tab up here so that you can do quite a lot of things with the molecular structure of your interest. And apart from zooming in, you can also hide and show the structure. So if you click H, which is hide, you can choose to hide and show most things. So if you hide everything, you will hide everything. And if you decided to show, you can show structures in different ways. You can show it as line, which basically all atoms as dot and all the bonds as line. You can also show everything as sticks, which means that you get a line, but a thicker stick. You can also show everything as spheres, where all atoms are represented as sphere. But you can see here, if you decided to show everything as sphere, you will not be able to see certain bits of the structures, i.e. it will be a bit dense, right? You can also decide to hide everything again and show it as cartoon as the most canonical normal representation, where alpha helix are represented as ribbon and beta strands are represented as a square arrow, where the arrowhead represent the direction of the protein from the N to the C terminus. You can also show the cell if you're doing a simulation box, which would then tells you the grid dimension. And you can also decide to show a surface around it, which would tells you roughly, based on the van der Waals radii, what are the surface of this protein going to look like. And you can also hide the structures. And let's now show it as cartoon again, and color the molecules based on your interest. So in this case, we have the whole thing as green at the moment. And I think in this structure, I put them all together as one chain, yes. So you can color these by their elements. So for example, if I decided to show this residue here as stick, so this is a tyrosine 372. So if you click on a certain part of the structure, you will see that the residue type and the residue number would come up, and the atom you click, which is Ca for C alpha, would also come up. So if I decided to show this residue as stick, I would have to right click on this, and then I can either right click and then action, show, as sticks, and it will pop up. The other easier way is if you click on any residues, you can then type show sticks, and then as you make a selection, you just click it, it is celle, so it shows sticks celle, and the stick at that residue would come up. Now, if you zoom in on these residues, what you can see is I already colored this by the element. So the carbons are represented in green, hydrogen in white, and oxygen in red. What I can also do is color this by element, but using different color scheme. For example, I can make carbon to be yellow, oxygen still as red, and hydrogen as white. And if you can see here at the backbone, you can see that the nitrogen is represented as blue. So you can color this any way you want. You can also hide the hydrogen. So if you go hide, you can also hide all the hydrogen, all the non-polar hydrogen. So that would leave us the hydroxyl group, which is a polar hydrogen, but all the carbon hydrogen would be gone. Sometimes you don't want to see the backbone because it looks a bit clunky. You can also choose to hide the main chain, which is the backbone, as well in these molecular structure. In the next tutorial, we will be having a look at how we're going to make pretty pictures of this. But for this first session, I think this is it. Thank you very much.